What's up, guys? In today's video I'll be going from dirt to this concrete slab right here for the garage and a mechanical room over here, going over everything from laying down some rock, compacting it, getting it perfectly level, 2 layers of insulation, getting heat sheet heavy in there which holds PEX for radiant floor heating, setting up the manifold over there, and finally finishing up with the concrete. So check it out. I went and picked up some 3/4 inch minus basalt and dumped it in the front of the garage there. Now I'm just spreading it out, setting it to some stakes, getting it fairly level, but not 100%. Because I'm also going to be compacting it, as you see I'm doing right there, with a plate compactor. It's very important so you don't have issues with settling later on. So I think I ended up with a total of 6 inches of compacted basalt. Here what I'm doing is using some metal bars, 1-inch square tube, and putting a light layer of sand on top. By doing that, I was able to get a perfectly flat surface for me to put the first layer of insulation down. And I'm just using the screed bar from my power screed to ride on top of those the bars. I finished up laying down the first layer of insulation, so I got 2 inches of rigid insulation here. Next, what I'm going to do is you always need a vapor barrier. So I have this Stego Home below slab vapor protector that I'll lay down. I think it's 15 or 16 mil. I was going to put it underneath, but because I was using the sand, I didn't want to have to walk on it and disturb it. Talked to the engineer. He said it's fine to put it in between the layers. I could even put it above, but since I am using heat sheet heavy on top of this, I'd rather keep it down here. So I'm going to go ahead and put that here. First, I'm going to clean off around the edges so I have something to tape it to, and then spread that out, tape all the seams, tape it to the wall, and then put my heat sheet heavy on top of that. I think it's only a 6 mil barrier that's required per code here, but this is the Stego Home 15 mil. Figure I might as well have some extra, and then whatever is left over I can use as a slip and slide in the summer. So here you can see I'm spreading it out. I cut it to the right length so that it could also go up a little bit up the side, but not too much, because I want to be able to have something to mark the level that I'm going to be setting the concrete to. So the snap lines don't really work well on plastic, so not too high up, but just high enough. And here you can see I'm going around cleaning the wall, because even though Stego tape is really strong, it's not gonna set to sand or dirt, so I had to clean it off first. Used a couple of rolls of kitchen towels. I got it done. You can see I laid down the first layer of the heat sheet heavy. It has those little notches in it that will hold the PEX perfectly in place. And it looks like I'm doing a great job. Almost done. I've gotten to the end here. You can see I had to cover the whole basic bathtub with a tarp because it's been raining a lot. So I had to wait for a while to do this beginning here. It's going to be a thickened edge, so you can see it sloped down a little bit from this last section of insulation. So I just got it sloped 3 inches deeper on one side than the other, and then now I'm going to put the plastic back over it again. I made sure it happened at a seam of one of these heat sheet heavies. And yeah, now we'll just get the plastic, we'll get heat sheet heavy, and then we'll be done with this one. Now it's more the same, but it's just on the other side of that little divider wall. This is the closest part for the camera is the mechanical room. Furthest away, that's going to be the entrance to the stairs going upstairs. Laying down that first layer, and we'll get some Stego, hopefully. There it is. Stego, got that blue tape all around. Check out my work, people. I have finished a sub insulation, then the Home Stego wrap 15 mil, Now on top, I put down the heat sheet. That's done. Next now is I am going to lay out the pecs. So I used Upanor's Loop CAD to figure out the layout. And I bought this pecs uncoiler off of I forget what the website was. I can put a link below. And hopefully this will make it easy enough for me to do it one person. Wish me luck. I'll show you how I connect up the manifold here. So per the instructions, you start with the return. So for me, that's this one. So what I do is I mark it. I mark it to right around up here. There we go. And then I thought I was smart and bought this tool for making it easier to cut it. Turns out this tool is for copper. Just like it was advertised. So all it does is make a pretty little mark on it. But it's definitely not made for it. So I do like the little indent it gets though. So I'm pretending like it was worth it by utilizing it. Now let's cut it. Try to not make it square. There we go. Let's snake it up in there. That's my. So now that it's cut to the right length, we put a nut on there. There we go. Compression fitting. And then tip. Get it deep in there. Put that in here. And just tighten it down. I think I got it on there. There we go. And then before we tighten it too much, just grab another one up on top so that you're not twisting it too hard into the body itself. There it is. All right, so we got that. Then we'll throw a label on it. So this is the return. So it's my middle, zone 2, return. Put that on and go on to the supply. There we go. All right, now we're on to the supply. So I marked it. We'll go ahead, cut it. Oh, wrong one. And just repeat it. Nut. Compression fitting. Oh, I lost that one. Compression. And then that fits right in there. Make sure it's cut square. Put it in center. Get up and lock. Sometimes it can be a little hard to get them started, but I got it. Let's hold on to the top. There we go. Tighten it up. Okay. Just do a little bit more, just because last time when I removed the top, it loosened up the connection to the body. There we go. All right, now a label, and we'll be done with zone 2. I have great news. I just passed the inspection for both the sill plates. Boom, right around here. and the PEX tubing in the insulation and the insulation itself. All was passed. When the inspector got here, I had finished about 30 seconds ago to set up the manifold. It's actually not supposed to be inspected for another 5 days, but luckily I was just done, and he got it signed off, and I'm good to go. So next now, I'm gonna put a wire mesh sheet over here, 6x6 openings, and yeah, that'll just reinforce it a bit. I went to Lowe's and got this wire mesh sheets. I just laid them down. Once I had them all laid down, I cut whatever custom pieces I needed and then tied them together just using rebar ties. Once I had it all tied together, I put the sheets up on rebar chairs. I have finally finished framing up everything for the concrete pour. If you look over here, I got the floor drain sitting there. Then here, we got a box that allows me to put this load pad a little higher than the floor. That's going to transfer the load from the ridge beam down to the ground. Then over here, this is what I'm the most proud of. It is the garage door. I didn't want to have a thermal bridge from the outside to the inside because I'm going to have radiant floor heating, as you can see in here. Well, maybe it's a little hard to see, but I have some tubes in there. So what I've done was I'm going to have a fairly level, well, all the way level floor until I get to the last 18 inches here. Then it's going to be a slope going to the outside. And what I'm putting there is this right here. This is called foam glass. It is very, very dense insulation. It can take very high loads, like a car driving over it, it wouldn't deflect. However, it does seem brittle, so I gotta have a good area for it to rest on that will support it. Then on top of that, in a bit of mortar, I'm gonna set this, it's a threshold that you would use in a gymnasium. Have that right where the door comes down. And so this will be bedded in mortar, then there'll be a layer of mortar on top here, and then this will be sat in that. So you can see here, I have framed it up. There is an opening underneath for concrete to flow in. And I'm just gonna fill it to the top of this right here, which has been set to with laser to be the same height as the rest of the floor. And on the side here, I have marked it. So here's the rest of the floor. There is the level that we're gonna go to off of here. And then comes to there, and you can see it's just this area that will be slanted down. So that was my idea for how to prevent a thermal bridge going across the threshold. If you have any other ideas, then please let me know, because I haven't seen it anywhere. But anyway, on to concrete. Let's start with the main garage section here. So what we're going to do is divide it into two bays going back. First here, you can see I wrote 1 and then an arrow going back. And we're going to go to that squiggly line. Then we're going to go over, do number 2, which is over here. Go on number 2, back to same area here. Then go to 3, go this way over here, leave a little empty, so if we have extra, then we don't have to shovel it out or shovel it into the next bay, but we'll leave this area to the last. Then we'll get into the mechanical room over here and the main entrance over here. So the main entrance, we're going to fill all the way up to the top of the ICF, whereas everything else is going to be lower, just like here. You can see it's going to this line here. Same over here, except for inside of this pad right here, that will go up to the same level as the top of the ICF, and that's a bearing pad. And then we go over here, you can see my radiant floor heating has been holding pressure for weeks now, or at least a week. Everything is set up, we have all the conduits ready, plumbing has protection around it. Here we have water and power coming into the building. And then, actually that's water. Back behind me was power and future out for photovoltaic. Right here we have the power screed set up. I tested it, had to do some maintenance on it, but it is working now. In here you can see this one tube that I added afterwards. That's just a hollow tube that will send a temperature probe down in. That will measure the temperature of the slab itself. Over here we have the power screed set up. Or that's a power trowel. Over here we got the come-alongs, 3 of those. We have a day 1 finishing aid, just in case I need it. We got the concrete saw, I'll be cutting it the same day. And then we have our trowels and yeah, everything else we need to finish. I did bring the edgers just because they're in my bucket. I don't think we'll be using that. All right, then it was concrete time. Started in that first bay. It went up against the edge and kind of smoothed it out. Went back this way, smooth it out, and then I knocked over the camera. So no more of that. Here you can see the final product. The pour went really well. We used hot water and an accelerator to make it set a little faster. I have done 1 pass on 2/3 of the big bay. Have not gone over here yet. I have just troweled the edges. It is a little misty in the air. According to the internet, there's a 0% chance of rain right now, so don't know where that came from. Anyway, once it sets up, we'll be good to go with the first pass on the entire thing. Still some bleed water on top, so I gotta wait. I brought the lights out because it's gonna be a long night. Trowel around the edges, and then power trowel, and trowel around the edges, and power trowel, and keep repeating. Good morning. It's the day after the pour. I yesterday laid down a layer of insulation on top here. I had a bunch of extra insulation, and then the tarp on top, just so we had one freezing night in the forecast, and that was yesterday. So right now I put a temperature probe down there, and it's showing that the outside air is 39 currently, and the probe that's between the insulation is at 57. So that worked out well. So right now I'm just gonna uncover everything and cut my relief lines. Final thing to do here today is I have to cut some relief cuts in the concrete. I think 10 by 10 is the industry standard for the longest or largest size possible. Ideally, I'm gonna do one at 11 feet right here, same this direction. That way I'll have one directly underneath this temporary wall that I'm gonna have here later on. So I got a concrete saw from Vivor, very good price. It also came with a water pump to keep the dust down. Unfortunately, I left that one uncovered outside, open up, and water got into the motor. So I have made a little adapter onto a garden hose with some Sega Reson tape. So here we go. The adapter blew out immediately, so I ended up just using the garden hose and holding it next to the saw as I was cutting. After I was done with that, I got the pressure washer out and started getting off any debris that was on there. A little bit of settling from some of the cream from the concrete. So made it real pretty. All right, boys and girls, that is it. It was by no means the perfect project. I did have some issues. I haven't shown you some of them. The thing that I was most proud of, my threshold here, this one ended up rising up in the concrete, so this is way too high. I have to go back and grind that one down and use a chisel, whatever I need to do. Then this one, you can see it's the perfect height. It has good height here that will hold the insulation. This here is just temporary. That's going to be knocked out. That's going to be a much harder insulation there. However, what you haven't seen is did not vibrate it well enough, so I have a whole area that I need to fill with concrete later on. Other than that, love this project. This has turned out super good. If I was going to do it again, one thing I would think about is as the power screed comes up against the side, if it ever touches the ICF, it can knock off a little bit of that insulation, and then that comes on the surface. If you don't catch it, it will be buried into the concrete, and then after I polished it, I can sort of see some of it up on top here, and with the pressure washer, I removed those little pieces of insulation, and now I have mini holes here and there, just tiny ones from where there used to be insulation. So anyway, just something to think about. Maybe protect it, or try to go all the way to the top and maybe tape the top of the ICF, just so that you don't have that issue. But that is it. Next for me is to finish the sill plate here. It's going to be a double sill plate. Then all them walls over there, the structurally insulated panel, or SIPs, they will be coming down here. I'll have to figure out how to get them off of the top there. It's a 10-foot tall stack, as well as carrying them down here. An 8x4 sheet of 8-inch thick ICF or SIP walls should weigh about 120 pounds. These are much bigger than that. So I got some lifting plates, I got ladders, and a can-do attitude, so we'll figure it out. So cheers, I'll see you in the next one.